Okay, I'm getting the thumbs up. We're going to go ahead and start. So this is the session on porting your IPv4 applications to v4, v6 dual stack. If that's not the session you intended to attend, then you're in the wrong room. The gratuitous why is this important slide, that figure is not actually updated as of last night. That figure is from a few days ago. As you can see, we have about 726 days remaining in the IANA free pool for IPv4. Given the 2-year development cycle on a lot of applications, it's time to get moving. There is a lot of text ahead in the slides. I apologize for that, but there just aren't really good, cool graphical ways to present this information. At least I haven't been able to come up with any, but if you have ideas, I'm open to them. Okay, the basic steps in porting your application. There's sample code available at that same URL, and you're welcome to use all of that example code. All of the examples are written in v4 and then ported to v6. There's 3 languages there currently, C, PERL, and Python. Coming soon will be Ruby and then probably Java. Change the variable names. If you change your variable names as you start changing structure types and such, then the variable names can actually act as a flag for the other places in your code that you probably need to update. I didn't do that in some of the cases further on because the code was simple enough, but sorry about that. It can actually be a helpful technique. It certainly helped in the C version. Look for the old variable names as markers. And then basically once you've done that, it boils down to the usual compile, repair, recompile, followed by test, debug, retest routine. The general changes, AFINet becomes known as AFINet 6. It's kind of a misnomer that it's AFINet 6 because it will actually support mapped v4 addresses as well as v6 in that address family. SOCADDR-IN becomes a SOCADDR-IN 6. Except that if you need something that sort of refers to enough space to accommodate either and or can be used as a pointer for both that can be cast back and forth as needed, there's this special structure called a SOCADDR storage that's defined that is guaranteed to be a superset of all of the different SOCADDR types supported on the system. Most of the structures have the same members, although sometimes they renamed them gratuitously. They have very similar constants, and mostly it's just the address size that changes in most cases. You may actually, depending on your application, have to check address scoping. v6 introduced a new concept of address scope, where you have link local addresses that are only good for the local subnet. They're not routed to other networks. You have site local addresses that may have a differing meaning as to what their particular range of routing is, and then you of course have global addresses, which are what we're used to dealing with in v4. Most of the applications you'll be porting from v4, that won't be an issue because that concept didn't exist in v4, but it's not really covered in these examples, so heads up for that. Other possible gotchas that are not covered in the examples, if you keep IP addresses in log files or have them as fields in your databases, things like that, you're going to have to resize those fields in the database potentially, and you may need to update your log parsers as well as your log writing software to handle that. And any other parsing or other routines that need to deal with IP addresses. Mostly these should be library functions, so you update the one library function and it pretty much accommodates for most of your code, but you know, it's something to look out for. With that, we'll delve into each of the 3 porting examples. Again, heavily referencing the handout data. The handout actually contains side-by-side diffs of each of the sample applications. There's a client and server for each language, and there's a v4 version of the client on the left side of the diff and a v6 version or or a dual stack version on the right side. And then all of the source code is easily downloadable from the same website, and you're welcome to use it for whatever purposes. So the easy part of migrating the server went pretty straightforward. There's an additional include file that you need for C, which is netinet/in.h. I renamed sockfd to sockfd6 just so that I could use it as a tag for finding things that needed to be updated. Sockadder structures changed to sockadder in6 as mentioned before, and I renamed the variable which was desksin to desksin6 so that I could track that as well. There's a few changes to the way that structure gets initialized in the process. There are some different arguments in the socket call, as well as set sock dot bind and listen. And then there are some changes to the variables in the socket related error messages. Am I going too fast, too slow, just right? Everybody sleeping? I'm seeing nods to just right. Okay, I'll continue then. The client migration was a little bit harder than the server, but it was actually pretty similar. The hairy parts of that were that you needed a helper function to front end the inet n2p call for the different possible return structures from getAtterInfo, depending on whether it returned an inet or an inet6 type structure. It's unfortunate that inet n2p was not written with the fact that that could happen in mind, such that it could just be called with that information. Get host by name, get serve by name, get changed out to getAtterInfo, which is actually kind of the Swiss Army get whatever by whatever solution. It's actually a lot easier to use once you learn to use it, but it is quite a different paradigm, so that changes things. And then the other big thing to worry about is if you use getAtterInfo, it dynamically allocates a linked list for you and returns a pointer to you in the thing you called it with. So that's that memory needs to be freed, or your application has the risk of leaking memory if you call it repeatedly. This is the eye chart warning. If you can read this, your eyes are better than mine. Copyright 2009 Hurricane Electric, all rights reserved. Moving on. So the old way, we did a get host by name and an inet adder call to parse it if it was an IPv4 address. The new and then we had to call this get serve by name to resolve the service. Multiple separate steps. The new way, we just call getAtterInfo with all the right arguments, and it returns everything for us. So you can see this is much simpler than all of the code on the previous two slides, and it does pretty much the same thing. The process of trying to connect is a little bit different. In IPv4, this is where it gets hard to read. We had to do a loop to try each of the possible addresses, but they were all IPv4 addresses, so we only needed to create one socket outside of the loop and then iterate over trying each connection on that socket with repeated calls to connect until we got a successful connection. In the new paradigm, we actually have to create the socket and destroy it each time within the loop, and that's because we don't know whether we need an inet4 or an inet6 type socket when we create the socket, so we have to create it inside the loop as we parse each one. The easy parts, again, use the same variable name flagging, mostly update the same structure names and calls through exactly the same method. GetAtterInfo will automatically return quad A and A records, so v6 or v4 is automatic with one code base. And inet n2p needs that helper function that was discussed earlier. So before we move on to PERL, what happens if we aren't ready? Well, this is probably a little more graphic than what happens, but it's something like that. Your IPv4 client, your IPv6 only clients are going to have a hard time talking to your IPv4 only servers. So moving on to PERL. Any questions so far on C? I went through that kind of quick. Okay, either everybody's lost or they don't care, or it's all working out well. Refer to the source code examples, again, same spiel. In the PERL case, I didn't bother renaming most of the variables. It's a pretty small code base and it's not that important. Add socket 6 to the modules used. You still need to call the socket module as well, but the other problem is that the PERL documentation for socket 6 is pretty minimal and assumes that you just sort of magically understand it's mostly sort of like socket, but not completely. There are some good examples out on the web, and hopefully by referring to this code you'll have the rest of the puzzle pieces if you need them. Gut and replace the get star by name calls, no surprise there, with get adder info. Change the protocol and address families in the socket and bind calls, and some minor changes to processing how incoming connections are handled. The biggest change is the get star by name to get adder info process. Similar changes to what was done in the C port, because underlying it is the same C libraries. The C get adder info returns a linked list. The PERL version does not return a linked list. Instead, it returns a single list, and you're expected to know that every fifth element in the list starts a new set of items, 5 items per tuple in the list. This actually turns out to be pretty easy to parse in PERL, and I'll show you how that's done on the next slide. One other gotcha I ran into in PERL is if you call getAdderInfo with in6adder_any as the argument, the returned value you get does not include in6adder_any as what you're going to bind to, and instead it gives you back localhost. So unless you are intending to bind to localhost and localhost only, you will want to change that in the returned structure before you call bind. That wasn't a problem in C, by the way, so I don't know why PERL does that differently. So the parsing routine, it's still a little bit of an eye chart, but you can see in the second line of the new way of doing this, @res equals getAdderInfo blah blah blah. Then we'll step through @res using basically, the 5 variables we want to stick the tuple into, comma @res equals @res, while fam does not equal AFINET 6. The reason I skip everything that's not an AFINET 6 entry is because I want to provide dual stack services with this one code base, so I want to only bind to the v6 address, and that way I'm binding actually to support mapped v4 clients as well as v6 clients on the one socket. And you don't have to actually create multiple sockets and all of that on most systems. There are a few systems where that doesn't work. Unpack sock adder in 6 is pretty straightforward and very similar to the v4 stuff. Any questions on this? Okay. IPv4 only version, we call socket, we call bind. Guess what? The IPv6 dual stack version, same thing, except we have to use PFINet 6 instead of PFINet. Big whopping change there. IPv4 only to dual stack, additional code changes. This is how we accept a new connection. Unpack the address. Pretty much the same process. We use get name info instead of get host by adder, and then the inet n to p instead of n to a for the logging information to be formatted. The client migration, very similar to the server, and even more similar to the C client. Add the same module, rearrange the address resolution stuff, add some handling for AFINET 6 to the connection loop, and convert inet into A to inet into P, and protocol family stuff for the socket call. Code changes. Same stuff. This is pretty straightforward. The getAdderInfo thing, Now we're actually going to just parse through it and connect to the first one that works. We don't care whether it's v4 or v6 as long as it just works. But in the loop where you're trying to connect, in IPv4, the socket can be recycled for multiple connections, but with dual stack, you again need to move the creation of the socket inside the loop so that you can create an INET or INET6 socket as needed. Same stuff as the others. The IPv4 only version of the connection loop. Clearly I'm spending too much time on some of these slides. The IPv4 only version of the connection loop and the IPv4 v6 dual stack version of the connection loop. As you can see, there's a lot more content inside the connection loop. It's not as bad as it looks. Mostly it's stuff that was outside, got moved inside the loop because you don't know ahead of time which kind you're trying. So before we get into Python, a more realistic look at what's really going to happen if people's applications aren't ready for dual stack. It'll be one or more of these situations where you end up with translating routers or multiple layers of NAT or TCP relays or this DS Lite thing that Comcast and a couple of other people have been working on, which actually is one of the more promising ones so far for how to do this if we don't have content on v6 by the time we're ready. Python. Actually, Python was the easiest language to do the port in, which pains me to say because it's not my favorite language. But mostly it's a matter of getting replace the get star by name calls and replacing the default fatal error process with a try process that iterates through the different possibilities. And some minor changes to how we handle incoming connections because it starts returning a 4 tuple instead of a 2-item tuple. Get served by name to get attr info, still pretty much straightforward. Listening, it's still straightforward, but we have to do this iterative process now instead of the original single attempt. And there's your 2-tuple versus 4-tuple change for the parsing the address that gets returned by connect. This is to use to make the address presentable in debug output and user messages. The client migration, pretty straightforward. Get attr info again. A little bit of handling for AF INET6 in the connection loop, and INET N to A to N to P protocol family in the socket. This is the way we used to try and connect. This is what we have to do now. Primarily, this expanded due to having to handle the 2 different families as possible returns from the resolution process. There's minor modifications required in a successful connection message because the variable names changed in the print arguments due to the family changes, and not a lot else needed. The slides are online on the agenda now, as I understand it. There's a handy function replacement guide that pretty much maps to all of the languages, and there's also a structure replacement guide at the end, so you guys can add those to your toolkit for porting your applications. I hope it works out well for you. Feedback is welcome at that address, and the presentation and all of the resources are also available on that URL. So seriously, questions, comments, discussion. We've got, it's 2:20 and a tutorial that was supposed to take 90 minutes from 2 o'clock. So. Yes, come on up to the mic. And they don't have to be porting related questions. If you've got questions about implementing v6, deploying v6, we're here to help.
Hi, I'm Larissa Shapiro. I'm from ISC, and I just wanted to say that the thing that you were talking about, the carrier grade NAT that we've done with Comcast, the first version is out there on the ISC website. So if you want to check it out, it's free. It's open source.
It's actually pretty good stuff. I think it's the most promising thing short of dual stack that's out there.
Thanks. I mean, it's an early version, but it's there. And feel free to come ask me more questions anytime.
It still breaks most of the things that NAT breaks, but it doesn't break all of the things that double NAT breaks. So it's better than double NAT, which is what most of the carrier grade NAT amounts to. Any other questions, concerns, comments, thoughts?
Can you go into a bit more detail on the, you had talked about changes to database structure and things like that when it comes from storing only IPv4 and storing both IPv4 and IPv6, how you actually designs?
Well, I didn't approach that in my designs because I wasn't actually storing those things. But in general, an IPv4 address is this big, and so you can store it, for example, in a varchar 15 if you really wanted to, or you can store it as a 32-bit integer. An IPv6 address is this big, and so you need to at least widen the fields, and you need to at least allow for the fact that the content may be in a different format if you're storing it as a string. And if you've got any routines that do parsing on that, and if you're doing address mask notation or things like that, you may need to update your parsing routines to allow for that, or make sure that you're using a parsing library that already does.
Hi. Can you quickly comment on any changes that you need to make for like porting Anycast-aware applications? Because I heard like IPv6 actually is doing something different now for Anycast.
I would love to. Unfortunately, I have not gotten completely up to speed on IPv6 Anycast as yet, so I don't actually know. But I will try and research that and know for next time. Yeah. Any others? Okay, well, I guess everybody has lots of free time they weren't planning on having. Thank you all for attending. And I hope you enjoyed the Thailand pictures. Oh, okay. I'm like trying to turn it off for you. I'm like, I don't know where the switch is. I see. It's probably wise. I have not run into that. So far, most of our customers have been able to do what they want to do with the 6 without too much trouble. But again, most of them are using their v6 tools that they're using are SSH, Safari, and Firefox, and so. I haven't run into any, but I don't do a lot of Microsoft stuff. Yeah. Yes, I believe friends don't let friends. I'm sorry. So sorry I didn't have a better answer for you on the Anycast stuff.